physical world and measurement? I repeat the question. The maximum error in the measurement of mass and density of a cube are 3% and 9% respectively. The maximum error in the measurement of length will be dash. That is, as you all know that density is equal to mass by volume. So rho is equal to m by L cube. Now in relative error, delta rho by rho is equal to delta m by m plus 3 into delta L by L. That is, mass is represented as m and volume in L cube. Since it is a cube root, then on writing the relative error, we will be writing 3 into delta L by M. On finding out the percentage, we multiply left hand term and right hand term with 100. That is, delta rho by rho into 100 is equal to delta m by m into 100 plus 3 into delta L by L into 100. On taking the length in the left hand side, that is 3 into delta L by L into 100 is equal to delta rho by rho into 100 minus delta m by m into 100. Since the question is to find out the maximum error in measurement of length. Hence, we take the length term on the left hand side. Now substituting the density value, that is a 9%, and mass value as 3%, we get the answer as 6%. That is, 3 into delta L by L into 100 will give the 6%. You have to find out the maximum error in the measurement of length. That is delta L by L into 100, which gives the answer as 2%. Okay. The question I repeat, the maximum error in the measurement of mass and density of a cube are 3% and 9% respectively. The maximum error in the measurement of length will be, the answer is option A, 2%. Moving on to the next question, that is, the dimension of a rectangular block measured with calipers having least count of 0.01 centimeter are 5 mm, 10 mm and 5 mm respectively. The maximum percentage error in the measurement of the volume of the block is dash. That is, the dimension of a rectangular block is given as length as 5 mm, breadth as 10 mm and height as 5 mm, and is measured with calipers having a least count of 0.01 centimeter. The maximum percentage error in the measurement of the volume of a block is dash. That is, as you all know that volume is equal to length into breadth into height. Okay, that is, V is equal to L into B into H. The maximum relative error in volume is written as delta V by V will be equal to delta length by length plus delta breadth by breadth plus delta height by height. Now, the maximum percentage error in volume will be written as multiplied with 100 on right hand side and left hand side. That is, delta V by V into 100 will be equal to delta L by L into 100 plus delta B by B into 100 plus delta H by H into 100. Okay. That is, all the delta L value, B value and H value is written as the least count, that is 0.01, and the length, breadth, height value as 0.5, 1 and 0.5. Okay. So the substituting the values, that is 0.01 by 0.5 into 100 plus 0.01 by 1 into 100 plus 0.01 by 0.5 into 100. That will be equal to 2% plus 1% plus 2%, which will be given answer as 5%. I repeat the question. The dimensions of a rectangular block measured with calipers having the least count of 0.01 centimeter are 5 mm, 10 mm and 5 mm. The maximum percentage error in the measurement of the volume of a block is option A, that is 5%. Moving on to the next question, that is, in a particular system of unit of length, mass and time are chosen to be 10 centimeter, 10 gram and 0.1 second respectively. The unit of force in the system will be equivalent to dash. I repeat the question. In a particular system, the unit of length, mass and time is given as length as 10 centimeter, mass as 10 gram, time as 0.1 second are chosen to be 10 centimeter, 10 gram and 0.1 second respectively. The unit of force in the system will be equivalent to dash. Now considering the given data, that is mass as 10 gram, length as 10 centimeter and time as 0.1 second. On converting these units to an SI system, we convert that is mass into 1 kilogram, length as 1 meter and time as 1 second. Now, the dimensional formula for a force, that is ml t raised to minus 2, that is m equals 1, L equals 1 and time equals minus 2. That is A is equal to 1, B is equal to 1 and C is equal to minus 2. Now equation, that is N2 is equal to N1 into M1 by M2 raised to A into L1 by L2 raised to B into T1 by T2 raised to C. On substituting the value, N1 as 1, M1 as 10 gram, M2 as 1 kilogram, L1 as 10 centimeter, L2 as 1 meter, time T1 as 0.1 second and time T2 as 1 second. Converting the gram, centimeter and seconds into kilogram, meter and seconds, we get the final as 0.1. That is, unit of force in a given system will be equivalent to 0.1 Newton. I repeat, in a particular system, the unit of length, mass and time are chosen to be 10 centimeter, 10 gram and 0.1 second respectively. The unit of force in the system will be equivalent to option A, that is 0.1 Newton. Next question. In an experiment of simple pendulum, the error in the measurement of length of the L and the time period capital T are 3% and 2% respectively. The maximum percentage error in the value of L by T square is dash. I repeat the question. In an experiment of simple pendulum, the error in the measurement of length of the L and time period are given as, that is length as 3% and time period as 2%. The maximum percentage error in the value of L by T square is dash. That is, the time period of a simple pendulum is represented as T is equal to 2 pi into root of L by G. Squaring on both sides, we get T square is equal to 4 pi square L by G. Hence, G is equal to 4 pi square L by T square. The maximum percentage error in G is delta G by G into 100 will be equal to delta L by L into 100 plus 2 into delta T by T into 100. Since T is in square term, we multiply 2 into delta T by T. On substituting the length as 3% and time as 2%, we get the answer, that is 3% plus 2 into 2% equals to 7%. From the first equation, that is T square is equal to 4 pi square into L by G. That is L by T square will be equal to G by 4 pi square. The maximum percentage error in L by T square is delta L by T square divided by L by T square into 100, that will be equal to delta G by G into 100, which is equals to 7%. I repeat the question, that is, in an experiment of simple pendulum, error in the measurement of length of the L and the time period T are 3% and 2% respectively. The maximum percentage error in the value of L by T square is option B, that is 7%. The question is joule into second is the unit of dash. I repeat, the joule into second is the unit of dash. The answer is joule is the SI unit of work and second is the SI unit of time. Hence, work into time will be equal to ml square t raised to minus 2 into t. That is will be equal to ml square t raised to minus 1, which is a dimensional formula of angular momentum. That is, the joules into second is the unit of angular momentum, that is option C. Thank you.